In this lesson, we're continuing talking about the concept of standard deviation, like the spread of the data from the mean, but now we're going to be talking about the sample standard deviation. So when we've been working with the standard deviation, this is representing a population. So the sample, remember, is just a small portion of the population. So to calculate standard deviation, we're going to take the population standard deviation, which is our sigma, but divide that by, we're going to take the square root of the size of the sample, which is our n. So again, our sigma here is still going to represent standard deviation. But this is, again, just a reminder, right, from the population. And n is the size or number from the sample. And that information will always be given to you. So just to practice using the formula, let's go ahead and do these few examples. Now, so we are going to be using the mean, population mean is 500, and the population standard deviation is 125. So we're just going to practice changing that value here. Now, keep in mind, notice that we only discussed how the sample standard deviation we're going to use by calculating here using our population. But remember, now mean is always mean. Mean is mean. No matter what, it will not change from the population even to the sample. They will always be the same. Mean is mean. So even if we just take a sample size of 100, the mean of the sample is still 500. Now, here to calculate the sample standard deviation, so here we go. We need to take the standard deviation here from the population, which was 125, and divide that by the square root of the sample size, which is 100. So now you can put that in the calculator and you get a new, so the sample standard deviation is 12.5. So again, even if the sample size is 200, mean is mean. So what is the mean for the sample of 200? Still 500. Then again, to get that standard deviation for the sample, we're going to take our standard deviation of 125 and divide that by our sample size, which is now 200. So put that in the calculator, and that is approximately 8.8. So go ahead, pause the video, and go ahead and do the examples 3 and 4 on your own. And here we go. So here again for a sample size of 550. Mean is still 500. Here, to get the sample standard deviation, you should have set it up 125 divided by the square root of 550, which is approximately 5.3. Then here, sample size 1,000, same thing. You have a mean of 500, and then 125 divided by radical 1,000. Here you get approximately 3.95. So before we continue on, what do you notice? What happens as the sample size got larger? What happens to the sample size of the standard deviation? It gets smaller, which means now we get more accurate data. We get a better reflection of the population. So keep in mind, the more samples that are taken, it's going to be a better reflection of the population. So now let's also keep in mind, what if we wanted to know what is the z-score, but of a sample size? So we are going to get into practicing identifying. There are 4 items to identify. So we're going to always be given the mean and standard deviation of the population, right? Now, we are converting to a z-score, so we're going to be given that x value. And don't forget, we're going to be, not an m, sorry, my fault. We're going to be given that sample size, Rn. So here we go. The heights of fully grown sugar maple trees are normally distributed. So here's our curve with a mean of 87.5 feet. So the mean is 87.5 feet. And a standard deviation of 6.25. So here's our sigma, 6.25 feet. What is the z-score that represents a tree with a height of 89.8 feet? So this is what we're converting. That is our x, 89.8 feet. Then notice from a random sample size, here's our sample size of 58. So n is 58. So now first step, if we're working now with a sample size, we need to get the sample standard deviation. We can't use the standard deviation for the sample. We have to use the sample standard deviation. So again, we're going to have our standard deviation of 6.25 divided by the square root of the sample size, which is 58. So here now we get approximately 0.82. So now here's what I would suggest. Notice how this is the standard deviation for the sample, right? So we don't need this standard deviation anymore from the population because we are using this for the sample. So we're going to use 0.82 when we are calculating. So now we can calculate the z-score. So remember, z-score was always, we subtracted the mean, remember, right? Mean is mean no matter the sample size. So minus 87.5 divided by the standard deviation, which is now what? 0.82, right? We're not using the original from the sample. What is the value that we are converting? 89.8. So that is our z-score. So our z-score is approximately 2.8. So again, we're going to identify to get our new sample standard deviation. So when we calculate our z-score, we always subtract the mean. Remember, right? Mean is mean divided by standard deviation. So we're going to use that value to convert to find our z-score. So let's do another one. The number of eggs female houseflies lay during their lifetimes is normally distributed. So here's our curve again with a mean of 800. So there's our mean, 800 eggs, and a standard deviation of 500. So here's our sigma, 500 eggs. What is the z-score that represents 928 eggs? So this is what we're converting. This is our x. From a random sample size, there you go. So here's our sample size of 35. That is our n, 35. So now with a sample, we need to get the sample standard deviation. So here we go. You take standard deviation, which is 500, divided by radical 35, the square root of our sample size. So put that in the calculator and you should get approximately 84.5. So now remember, right? We're not using a standard deviation of 500. Now we have a standard deviation of 84.5 for our sample. And then technically now we're also done with calculating. We don't need the sample size anymore. So now we can calculate our z-score. Subtracting the mean, which is 800, mean is mean, divided by the standard deviation, which is now 84.5. And what value are we converting? 928. So now the z-score we can calculate, which is approximately 1.51. So go ahead and pause the video and try number 3 on your own. And here we go. So as you go through a reading about the Ford Escort fuel efficiency, you should have identified our 4 pieces, right? The mean is, or average is 27. The standard deviation for the population is 1.6 miles per gallon. Our X value that we're converting is 29. And our sample size, right, is 125 Ford Escorts. So the first step you were supposed to do was get that sample standard deviation, which is taking the standard deviation of 1.6 and divide by the square root of 125. So the new sample size that you should have gotten for the standard deviation was approximately 0.14. So now that is what you should have used to calculate the z-score. So again, we didn't need the value anymore, right? We use that to calculate our new standard deviation. And you should have set this up as 29, that's your x, minus the mean, 27, divided by the standard deviation of the sample, which was 0.14. So the z-score you should have gotten was approximately 14.29. So now let's go ahead and calculate the probability, but of a sample. So here again, we are still going to identify what is the mean. So reading through this problem, what is our mean? What is our average? Average is 57 minutes. Then we need the standard deviation. So what's the standard deviation? 12 minutes. Then here, the length of the time is normally distributed. Our random sample of 64. So what does that 64 represent? If that's the sample size, your n. So 64. Then what is the value that we're going to be working with? 60 minutes. However, we're looking for the probability that the sample will average more than 60 minutes. So keep in mind now when we set up, you can either use the z-table, so converting the z-score, or using the calculator to set up your lower bound, upper bound to find the probability. But before we do that, because it's a sample, we do need the new standard deviation for the sample. So standard deviation 1200 divided by the square root of which value? 64, right? Because that's your n. So now the new standard deviation for the sample is approximately 1.5. So again, right, remember, now we're using 1.5, not 12. We don't need the sample size anymore. We just need that to convert. Now we can set up, and now the majority of the class uses the calculator and not the z-table, so I'll stick with showing you guys in the calculator. So to find the probability, here we go. We need lower bound, upper bound, the mean, the standard deviation. So again, the mean is 57, right? Mean is mean. But now we have a sample. So the standard deviation that we're going to use here is now 1.5. So now let's go back. More than 60. So where does that 60 need to go? Is that the lower, is that the upper if we want more than 60? It's the lowest, more than. So the upper bound is 1 million. So now we can put that in the calculator. So this is when we would press second vars, then go to option 2 for the CDF. Lower bound 60, upper bound 1 million. Mean is 57. Standard deviation for the sample is 1.5. And so that's why here you get about 0.02 rounding up to 3. So the probability is 0.023. So here, number 5. Same thing. We're going to identify our pieces. So here, go ahead and pause the video and identify the mean, standard deviation, the sample size, and the X value that we are converting. And here we go. So for the cholesterol levels, you should have identified the average is 260, standard deviation is 25, sample size is, oh, I forgot to, sorry, as you guys I'm sure probably did this on your own. I forgot to mention, we're going to use 60 here, so we have a different sample size. So my fault on that. So N was supposed to be 60, sorry, not 64. and the X value that we're converting is 258. However, because now we're looking for the probability, what's the key phrase in front of our 258? Less than. So keep that in mind. So here we go. First, because it's a sample, we need to convert to get our new standard deviation. So standard deviation of 25 divided by the square root of 60, the sample size. So here the new standard deviation is approximately 3.2. So again, no longer 25, right, but 3.2, and we don't need our sample size anymore. So now to find the probability, lower bound, upper bound, the mean, the standard deviation of the sample. So the mean again, mean is mean, 260. Standard deviation is now 3.2. So now we're converting the 258 to figure out the probability, but less than 258. So if we want less than 258, that is the highest value, the upper. So the lower is negative 1 million. So now here, again, second VARS, go to CDF, but now negative 1 million. Three. The upper bound, 258, 260, and 3.2. So that's why here, and rounding up, 0.266. So 0.266 is the probability. And of course, if we want to write that as a percentage, just move the decimal 2 times, right? Multiply by 100. So here we have 26.6% as the probability. Go ahead and pause the video and try the last 2 questions on your own. And here we go. So for question number 6, you should have identified the mean as 11.2 years, standard deviation 2.1 years. The X value is actually a range from 10 to 13 is what we're converting. And then your sample size N is 25. Again, I forgot to change the 64 to 25. Sorry, that's my fault. So if you did 64, that's fine. Then you should have set it up correctly. Otherwise, I'll be using 25 here. So the first step was to convert. So 2.1 divided by the radical 25. So here, new standard deviation is approximately 0.42. So that is what you should have used to solve, and we're done with our sample size. So identifying lower bound, upper bound, mean, and standard deviation for the sample, which is 0.42, mean is mean, 11.2. Now, because of the range 10 to 13, you were given the lower and upper bound. So when putting that in the calculator, you should have gotten 0.998 or 99.8%. Then question number 7. The mean was a score of 75 on the exam. Standard deviation was 6.5 points. The X value, the test score you're converting, was a 72 with a sample size N of 20 test scores. So now here, when you converted, you should have done the standard deviation, 6.5 divided by radical 20 to get a new standard deviation, which is approximately 1.45. So that is what you should have used to calculate the probability. Then we are done here. Now, the key phrase was also at least 72. So when identifying your lower bound, upper bound, mean is mean, so 75. Standard deviation of the sample is now 1.45. At least 72, so 72 was the lower bound. Upper bound, 1 million. So when you put that in the calculator, you should have gotten a probability of 0.981 or 98.1%.